Now, part C of the question. The terrarium on the right is a cube which is tilted and shaped as shown. The outline plan is a regular hexagon of 150mm side. Draw the given plan of this terrarium and project the elevation. Now, first of all, the outline there, as it says, is a regular hexagon. The hexagon is inscribed in a circle. If you remember back to junior cert, the radius of the circle is equal to the length of the side of the hexagon. So the side of the hexagon is 150mm, scale that back is 50. The radius of the circle is 50mm. So I will begin by drawing my radius 50 circle. And then with my compass, kept to radius 50, I'm just going to swing off my arcs on the outside of that circle, and I can draw in the outline of my hexagon. Now the triangle which is inside of that outline hexagon is an equilateral triangle. The sides being at 30 degrees. That there will complete our plan. So the next step then is to project all of our points straight up to the elevation. And we will then work out the angle. Now the next thing then, as we can see here, we have our angle inside of a semicircle, and that gives us this 90-degree corner which is highlighted as shown. I now have the diameter of that semicircle, as you can see, so I need to bisect this line along the bottom and draw in that semicircle. So there's my semicircle, and I will now follow up the very centre, and where that hits the semicircle I can draw in my 90-degree angle. And to finish off then my view, I will just extend out those edges, and everything else then is parallel to these two lines. And there then is the finished elevation of the cube. Next then, determine the true inclination of surface D to the horizontal plane, hence or otherwise determine the true shape of surface D. So first of all, determine the true inclination of surface D to the horizontal plane. Now, where we would have seen this before is in our geological geometry. That will be the very same as when you were asked to find the dip of your stratum. So where you have your surface, your lamina, and you're asked to find the dip. This is the very same idea. So we need to get an edge view of surface D. Now, if you notice, surface D has 5 vertices or corners, and one of the edges of surface D is horizontal, which means in plan that is a true length, which we can look along, similar to the strike. I'm just going to label the 5 corners. As you can see, 1, 5 is a horizontal line. I'll follow my points down. Like so, and now we're going to look along the line 1, 5, which is inclined at 30 degrees, and I'll project my other few points up there as well. Heights then from the elevation. And 3 is just slightly off my page there. And that then, the angle in there is the true inclination to the horizontal plane. Second part of part D then, hence or otherwise determine the true shape of surface D. What I am going to do, so 1, 5, if we've already said, is a true length line. I am going to rebat this surface until it sits on my x1, y1 and project it back. So I'm going to rebat it along the edge 1, 5. Just until it hits the xy. to highlight that now. Okay, I'm rebatting my points. I will then project them back down. And lastly then, because I'm rebatting it along the line 1, 5, these points would be projected perpendicular to 1, 5 for my true shape. So just to go over that again, so I've projected point 2 up, rebatted it, projected it back down, and then projected it 90 degrees to the line 1, 5. I'll just put in a few arrows there to highlight how I found point 2. Lastly then, I'll join 1 to my new point 2, follow point 3, 3 to my rebatted point 4, and back to point 5. And that there would be the true shape of surface D.